Hi everyone, I'm Oleksandr, obviously, and today I'm going to talk about testing MCP servers. We'll do a general introduction about testing in general, why and how to test MCP servers, and we'll talk about the performance testing specifically with a little technical deep dive. And I'll also show you an open source tool for performance testing called K6 and an extension for this specifically created to test MCP servers. So let's start. I promise the technical deep dive is going to be relatively simple because I see that maybe everyone is already a bit exhausted. So yeah, let's continue. So why testing matters at all? I don't pretend to be a testing guru, and obviously this list is not exhaustive, but just to give some key points, testing gives confidence to developers and the company when they release software or push changes to the existing software, because obviously they are confident that it works and it solves the problem that it's supposed to solve, and it actually is secure and reliable. And testing also helps mitigate some risks. Well, obviously, if the test results are addressed correctly, specifically the user trust risks, the security risks, revenue loss risks, and so on. And in general, it can boost user satisfaction because users will definitely prefer the software that is reliable and secure over the unreliable competitor. So what are the testing types in general? They can be split into two groups corresponding to the software requirements. The first group is functional testing. Obviously, we test if the software performs its functions correctly, if it does the thing that it's supposed to do. For example, if the tool in the MCP server does what it's actually supposed to do, maybe send an email, for example. And obviously, this can be achieved. This type of test can be done in different ways, which are unit integration, system smoke, and so on. I'm sure many of you know the other types. And then there are non-functional tests, which are supposed to test, obviously, non-functional requirements. Yeah, as I said, we'll touch the performance tests in detail, specifically in this presentation. So what are the possible issues in MCP servers? So we can have broken tools, which will also be the case of not properly tested functional requirement. We can have privilege escalation issues and leaking user data in our MCP server, which will be the example of the security risks. I'm sure all of you have heard plenty of examples during today's sessions about this. The MCP operation can be brittle or unscalable, so our MCP server may not be scaled properly to satisfy the number of users that actually want to use it. And obviously there can be low performance, which will lead to the poor user experience, and possibly even bigger issues if the workflow is critical. So one interesting quote that we've heard from one of our customers is that users expect very quick responses or they abandon quickly. They've said it specifically in the context of MCP servers because this is really important for products that rely on MCP servers to boost their adoption or market outreach. And yeah, we generally agree with them, although obviously it kind of smoothes out with how the LLMs respond. So obviously they are not as quick as one would want. But yeah, how would you test the MCP server reliability? In essence, the remote MCP server over HTTP transport is a web server. So one way, obviously, is to just release it, instrument it, and see how it reacts to the current user load. And you'll definitely be able to see if it succeeds or not, because if not, then the customers will reach you to your customer support and complain that your service is unusable. And yeah, hope no one sees threads on Reddit about how the users don't want to use their software anymore in their lifetime. But yeah, the proper way is to actually simulate the synthetic load on the MCP server using synthetic MCP clients. And this is something that can be done pre-production, obviously in secure environment, in isolated environments, and it's definitely more complicated than just pushing the software to prod. But as I said, it has its own benefits. And obviously, if your team has the resources to do this, then you should definitely do this. And there are numerous products to do this, to simulate the load. Obviously, the load testing industry has existed for a long time for the regular web services. Now the MCP are popular. It took off in that direction too. And there is a tool, open source tool called Grafana K6, which we can use to test not only MCP, but any service in general. It's basically a performance testing tool that allows you to spawn synthetic users that will continuously do requests to your service, generate synthetic load, and produce some metrics. So the most basic K6 test looks like this. It's a JavaScript test. And the K6 itself is written in Go, and it has its own interpreter for JavaScript. And the breakdown of the script looks like the following. At the top, we have the imports to import the necessary models to perform the test. There is an options object which allows us to configure the parameters for the test, like the number of virtual users and its duration, and many other parameters. And the last one is the default function, which is basically the entry point for the virtual user. And one virtual user is a lightweight thread that will continuously execute this function over and over again, depending on how many iterations you specify in your options or how long you want your test to run. So in this super simple example, we just continuously do requests to the Quick Pizza website and sleep for 1 second to just simulate a bit more realistic load. And at the end of the test, we get some summary, which lists our metrics duration, the number of requests, and some metrics related to execution and network bandwidth. And the last one is especially important for MCP that transport large volumes of data, generate images, and produce research and so on. So let's see how to write a test with K6. Hope demo gods will have mercy on me. Okay, so starting with the raw K6, this is basically the tools that are available in the K6 out of the box. I will just use the HTTP model to create requests, and with some vibe coding, we now have the MCP HTTP client, which basically implements the MCP protocol to connect, list tools, invoke tools, and get resources, and so on. And the script for this test is also very simple. We just do the most basic stuff like pinging the server, listing all of the primitives, and calling some tools, one of which is supposed to execute quickly, and the other one is less performant. So how do you run a test? Well, just ask K6 to run it. K6 run. I'm using 2 parameters to print the extended summary mode and disabling log output just to make it less verbose. So now the script is running. I have a simple MCP server running in background on my local host, which is MCP everything from the MCP community. And we are connecting, executing iterations, and getting a simple summary, I hope. Yep, there we go. So we can see that here we have a lot of interesting metrics related to HTTP. So these are the general request duration, then the breakdown for at the different stages of the request. But obviously, it may not be that relevant for all of the MCP use cases. It definitely has its value if you're trying to build a gateway and you need to evaluate performance of these specific stages. And the other downside is that you basically have to maintain this self-written client in JavaScript, and in general, it's not that plausible experience. But there is an alternative. K6 supports extensions, These are things that basically allow you to extend the standard K6 binary with your own stuff to test your own use case or implement your own protocol. So the examples of the extensions are XK6 Faker, Kafka, SSE, and many more. And the way they work is that you use a specific building tool called XK6 to build a new binary with your custom extensions. So for this presentation, we've built a K6 extension specifically for testing MCP servers. Essentially, it's a wrapper over the Anthropic client in Go, and it exports the definitions of the Anthropic client into the JavaScript so that you can use them when you write your test. So it's pretty basic. And the test written with this client now looks like this. At the top, we have the import from the extensions, just MCP module. And this module allows us to define the MCP client over different transports. So this example uses the streamable HTTP, but we'll also briefly touch the STD-IO closer to the end of the presentation. And essentially, this script is the same. We just implemented it with the extensions. And let me find the... OK, let me maybe quickly start it. And we'll start the plain one. Now this one is a bit more complex because it actually generates more load. I will use the Grafana Cloud product to visualize the results because out of the box the K6 only prints the summary, and it's always nicer to look at some dashboards to see the results. So we are running this test for 1 minute with the 100 virtual users. So this is equivalent to 100 MCP clients calling and connecting and working with the MCP server. Now, if we look at the results of one of the previous tests that I executed earlier, we can see here the dashboard that shows us the request rate and response time of the MCP server, and also the number of virtual MCP clients that are connected to the server. This is a very plain case with the constant number. And what we can do is to analyze this metric, and we will find that here we have a new metric, two new metrics that start with MCP. These are MCP request duration and MCP request count. And these metrics, they are specific to these extensions, and they created specifically to measure how well the MCP performs. Now, if we go to the Explore view, we can find these these metrics here. And what we can do as well is to group them by method to have a better example of what is really happening. And you can see here that overall the MCP client performed really well. The only downside is the invocation of the tool, which is called long-running operation, obviously. And these values are in milliseconds, so it takes 10 seconds to execute the tool, but otherwise everything is very quick. Well, obviously, because I'm running this on my local host. But basically this allows you to inspect your the metrics related to performance of your MCP server, evaluate the tools, maybe find bottlenecks, find which tools need some attention and have to be improved, and how your MCP server deals overall. And all this can be done before you actually release your MCP server to prod. Now let's touch a bit more complex example. If you want to use this type of test in your CI, and make it automated, you can define thresholds for your test and for specific metrics. And thresholds are essentially a limit that you want your system on the test to satisfy. When K6 runs, it produces metrics, and the thresholds are evaluated based on these metrics. And you can use some query expressions to actually specify what exactly metrics you want to evaluate. So in this example, we are evaluating the MCP request duration that is specific to the long-running operation invocation. And we want the 99th percentile to be less than 10 seconds, which is obviously not possible because the tool is hard-coded to 10 seconds. And we can explore the results of this test in the UI as well. You'll find that the threshold has been breached, the test has been marked as failed, and the K6 binary actually mentioned this in the output and returned a negative and returned an error code. So this can be used to actually fail the CI if you introduce a degradation in the MCP server. Another thing that K6 allows to do is to mimic different load patterns to generate load on the MCP server that mimics different load patterns. And this is especially useful to have different kinds, to run different kinds of tests on the MCP server. For example, the most popular kind is just the constant number of virtual users, which we ran previously, but you may also run the ramping number of users, which progressively increases the number of MCP clients during the test. And this way you can find at which point and what exact number of MCP clients your MCP server degrades and starts to be brittle, processes the request for a longer time, and becomes in general unstable. The other type is spike request rate, and used specifically for spike tests. So this is the type of test that simulates a spike of the load in a very short period of time. Usually this may happen if you just release your MCP server and someone mentions it on Twitter or finds it funny or finds a funny bug in it, and then you suddenly get hundreds or thousands of users using MCP server, even though you did not predict this. And that's why you use stress testing. You basically want to ensure that your service can properly rate limit this increased load or autoscale properly, and but yeah, at the same time, not to eat all of your budget for the cloud costs. And the other type of test is soak test. Soak testing is mainly useful to find memory leaks in your service. And the way it works is you also use the constant number of synthetic MCP clients that continuously use your service, and you may run this test for hours or days. And at some point, you may find that your service actually fails because there might be a memory leak, you're not clean up something properly, or there is an increased number of files in the file system, and it slows down the service. And so this is something that you should pay attention to. And yeah, an example how this load looks in the visualization. Here we go. So you can see that this is kind of irregular pattern here because we run all of these scenarios in parallel. But what K6 allows you to do is to actually filter the metrics for each scenario separately. Here they are just aggregated, but the interesting thing here is that you can see that even locally I managed to kill my MCP server, and at some point it just the response time increased and the request rate went down, probably because there is indeed something wrong with the example. Now. So just to recap quickly, we've generated synthetic load on the MCP server. We've defined thresholds to measure the server performance and evaluate what is acceptable and what's not. We've emulated different load patterns with scenarios in K6 to simulate different usage behaviors of the users. And yes, one last thing. Sorry about that. One last thing is that what I promised is that this MCP extension also allows you to use the std.io transport. Well, obviously, it's not that useful for performance testing. because obviously there's going to be likely one user of the MCP server that runs locally over std.io. But K6 also allows you to write functional tests. And for this, you may use a little library that creates assertions to be used in the K6 script. And if we run this type of test, if we run this type of test with the assertion, we can see that I've defined, well, an unrealistic assertion for the add tool. In one assertion, we expect the result to contain 3 and in another 4. And obviously, the 4 result fails, and it fails the entire test. And this way, you can actually also use K6 to write functional testing. And what's good about it is that they are not that different, essentially. And even in this library, you can disable an assertions and convert your functional test into the load test. So that's it. Yes. The next steps might be to configure this K6 test in your CI, run the test continuously, and what's more important, probably the most important part, is to actually act on the test results, because usually they are lost. Well, very often they are lost, and users get no value from this type of tests. You can find more information on these links. And yeah, let me know if you have any questions. I thank you all for the attention.